quadratic functions in factoring, graphing from intercept form. There's another name that we can call intercept form. Sometimes it's called in other places. And I'm not going to make you do everything on every graph. So there's going to be need to haves and nice to haves on graphing from intercept form. Because I hope if push comes to shove, because you know what a function is, you could always graph all the details if you really had to. So I'm going to start by actually graphing one of these. I'm going to start by graphing y equals x minus 6 times x minus 2. And we got to remember that it could also look like this, that function notation for our purposes right now. It doesn't do anything different. Just think of it as the same as y. But I want you to keep thinking more and more. What does it mean to be a function? If it's a function, I could always plug in any value for x, and I should get a unique value for y. So what does this look similar to? Well, it looks similar to when we factored quadratics and were able to solve them. Well, if I am doing this, what I'm saying is, when y is 0, what is x? And I'm going to get two answers to this one. I can set up this little baby equation and get x equals 6. I can set up this little baby equation and get x equals 2. And so those are my x-intercepts. So when we're graphing lines, we graph starting with the y-intercept. When we're graphing quadratics, when we're graphing parabolas, we start with the x-intercepts. And from intercept form, that is. So we have 6, 0, and we have 2, 0. And if we try to graph it, I know it goes up from there. A is 1, same old 1, and I'll talk about that in a minute. It's still right in there, and since there isn't one, there's my A. So I know it goes up and gets wider. I know it gets up and gets wider, but I found, if I try to do this, actually that one's pretty darn good. I'm going to leave that. Usually when I try to do that, it doesn't work out. What I was going to say is, gee, if I could just figure out where the middle of this is, it's easier to do. Well, I know where the middle is because I can just count over. Let's see, 1, 1, 1, 1. Oh, there's the middle. So I know that that's my axis of symmetry. So when we talk about our nice to haves and our need to haves are that my x-intercepts are 6, 0 and 2, 0, and that my axis of symmetry is always right in the middle, right in between them. So in this case it's 4, because that's 2 from 2 and 2 from 6. And what I was going to say is graphing, I find it easier to then kind of go down to meet in the middle. But again, I came up with this. I don't know if that's where the vertex is. The vertex is going to be a nice to have. If it's close enough and you know that A is 1 and you know how to count and you can figure out exactly where it is, great. But if you can get it pretty darn close and not perfect, great. That's going to be good enough for our purposes now. When you go on to higher math, you can do it more exact. But we just want to be able to relate this to factoring and be able to relate this to vertex form and be able to relate this to standard form and see how they all fit together. So now let me talk about what the format looks like by itself, the actual formula or equation. So what does intercept form look like? If you look at it, it looks scarier than it does when you see how easily we did what we did, because there's P's and Q's, and all we're saying is if you have intercept form, A does the same old things it's done, and you're saying that P, 0 and Q, 0 are your x-intercepts. And again, if you're graphing, it's easiest to count to get your axis of symmetry, but you can think of it, if you have two things and you're trying to find the middle of them, what do we call that? You have two test scores, we want to find the middle. you have two whatever scores you want to find the middle. It's add those two things together and divide by 2. You're really just finding the average or mean of the x-intercepts. Again, notice when we graphed it, I just counted. That's perfectly fine. Sometimes it's going to be a fraction. If your x-intercepts are an odd number of numbers apart, you're going to get a half, right? Or a decimal of some kind. But if they're an even number apart, you just count and you're in the middle and you're good. So those are going to be our need to haves, right? Our need to haves are going to be the x and y intercepts and the axis of symmetry. But the axis of symmetry, you don't have to calculate it. If you can count and tell it to me, awesome. Nice to haves, right? So these are need to have, need to have. Nice to have is going to be vertex, if you can tell, and y-intercept, if you can tell. I'm not terribly concerned. So we have y equals negative x plus 2, x minus 4. Well, this time, a is going to be -1, so we know it's going to open like that. It's not stretched or shrunk, so it's going to be kind of the normal size, normal shape. I'm not going to do the work to show the x-intercepts because I want you to want to show you it's just this easy. I know when the coefficient of x is 1 there, I know it's just the opposite of what I see. I know this one's just the opposite of what I see. Not that. That's not opposite. It's just the opposite of what I see. I solved this little baby equation, but I'm not going to even leave that up there. So those are my two x-intercepts. And I could do the math to figure out what's in the middle, but I find it easier if I've got the visual going. I'm a visual person. I go, those are 6 apart. So the axis of symmetry is going to be, let's change colors. The axis of symmetry is going to be 3 away from both of those. So my axis of symmetry is going to be +1. It's going to open up, and those are pretty far apart, so I don't even know if our vertex would truly fit on here, right? But I'm going to say it would be, up there somewhere. Very ugly, but that's perfect for our purposes. Right, those are our x-intercepts. Very ugly, but very effective. Let's do one of the special cases. Remember this special case? Think about what that equation would look like before it's factored, because that's where we're ultimately heading, is graphing from standard form. And if you factor it, way easy to graph, right? My x-intercepts are going to be -2 and +2. So x-intercepts are also called solutions because they're solutions to the equation if we set y equal to 0. My axis of symmetry is going to be 0. So when we did, I think it was when we did vertex form, I gave you several of these. And this one, I know exactly what the y-intercept and vertex should be because it's a special one, and the sooner I can get used to that, the better. That's still a nice to have for you, but if you want to be a, an A-B student, tell me what the vertex is. Tell me what the y-intercept is. How do I know that it's -4? Well, if I multiplied this guy out, it would be x squared minus 4. So I know that that factors to this, and I know that this C would be my y-intercept. Lots of reasons I know. 2, 0, x-intercept, -2, 0, x-intercept, my axis of symmetry, is x equals 0. And again, nice to have. See about why I know this. It's a vertex and a y-intercept. This is nice to have. Okay, and again, you can tell me that it's a minimum, that the minimum is -4 when x equals 0. Again, all that's A-level work. So if you can do that, you are in awesome shape. What if they're the same? You know, sometimes when you factor, you get something that looks like this. Well, okay, if I solve that one for 0, I don't have to write it twice, I just get 1. So that's one of those ones where you just have one intercept. You only have one intercept. And again, this is one where if I remember, oh, A is 1, so I know it's going to cross, it's going to go up 1 and over 1 for that first point. So it's only got one x-intercept, -1, 0. It's the x-intercept and it's also the vertex. Telling me it's the vertex is important on this one. There's no reason you can't tell me that's the vertex. It has to be the vertex. Nice to have is that the y-intercept is 0, 1. If you can't tell me that, that's okay. We'll get there eventually. We'll learn lots of ways to relate these things together. Axis of symmetry comes from the vertex, so you've told me that's the vertex. You know, there's no averaging these, there's only one of them. So it's just x equals -1, and that's it. So that's one of those perfect square trinomial ones. The last one before this one was the difference of squares type. Leave these for you to reflect on. That's it.